Hello everyone. Today we'll be discussing thermodynamic and kinetic products. We normally observe thermodynamic and kinetic products in a reaction where there is a possibility of forming two products. So whenever there is a possibility of forming two products in a reaction, one of the products is usually thermodynamic and the other product will be kinetic product. So in this class, we are going to consider some conditions that will favor the thermodynamic product and also conditions that will favor the kinetic product. One of the conditions that can favor whether it's a thermodynamic or kinetic product is temperature. Let us consider the reaction below. So in this reaction, temperature plays an important role in determining the outcome of the product, whether they will have the kinetic product more or the thermodynamic product. So reaction of cyclohexanone with sodium cyanide and when treated with water at 5 to 10 degrees Celsius affords the kinetic product where we have the substitution in 1,2 position. So in the thermodynamic product, the same reagent, sodium cyanide, treated with water at 80 degrees centigrade gave the thermodynamic product, which is the substitution in 1,4 position. So here, the temperature plays important role in determining the product that will be favored, whether it is the kinetic product or the thermodynamic product. When we raise the temperature using the same reagents, which are reactants, which is sodium cyanide, we observe the thermodynamic product, which is the substitution in 1,4 position. But when the reaction is carried out at a lower temperature, like 5 to 10 degrees Celsius, the kinetic product will be observed. Another important factor that determines which product will be favored is steric factor. Let us consider some example where steric factor plays an important role in determining which product will be favored, whether it is kinetic product or thermodynamic product. So in this example, steric factor plays an important role in determining which product will be favored. Here, the product that will be favored depends on the stability. The more stable compound is the thermodynamic product, and the less stable enolate. This is the enolate. The more substituted enolate is the thermodynamic product, whereas the less substituted enolate is the kinetic product. Here, they use the same base, which is LDA, at a very low temperature. Here, temperature does not determine which product will be favored, but what actually determines which product will be favored is the steric. In the kinetic product, we have the enolate formed in the less substituted carbon, which is the kinetic product, and it is less stable. In the thermodynamic product, we have the enolate ion formed in the more substituted carbon, which is more stable. In this example, stability plays an important role in determining which product is kinetic and which product is thermodynamic. And one thing we are supposed to bear in mind is that kinetic products are formed faster, while the thermodynamic products are formed slower. They are not formed immediately. The reaction takes time to form the product. Another important example that determines which product will be favored, whether it is the kinetic or thermodynamic product, is the nature of base. In the nature of base use, we can have soft base and hard base. So let us consider an example. Another important example is the nucleophilic addition. Here, the cuprate is a soft base. Then the alkyl lithium is a hard base. is a hard base. So when we use a hard base, we usually have the 1,2 addition product, which is the kinetic product. But when you use a soft base, we usually have a 1,4 addition, which is a thermodynamic product. Having a full knowledge of the reactivity or the nature of base you have, you can actually predict the regioselectivity of the reaction. So using a soft base usually give a thermodynamic product, and using a hard base usually give the kinetic product. So I'm going to put down the energy diagram of kinetic product versus the thermodynamic product, which will actually give us a clear illustration of the reactivity and the stability of the two types of products. I have my energy on the vertical axis. On the horizontal axis, I have my reaction coordinates, my starting material. This should be my product. This is the kinetic product. And this is the thermodynamic product. Here is my delta G double dagger. Here is my delta G. So if you have a look at the energy diagram, you observe that the kinetic product has small activation energy, which shows that the reaction is formed faster, but is less stable compared to the thermodynamic product that actually forms on a slower rate, but the product is much more stable. So this is the energy diagram that actually differentiates the kinetic product and the thermodynamic product. So in summary, kinetic products are formed faster, while thermodynamic products are formed slower. Then secondly, kinetic products are irreversible, while thermodynamic products are reversible. The third important point, low temperature favors kinetic products, while high temperature favors thermodynamic products. Kinetic products are less stable, while thermodynamic products are more stable. Kinetic products requires a stronger or hard base, while thermodynamic products requires a soft or weaker base. In my next video, I'll be explaining in details the difference between a soft base and a hard base, and how you can actually predict which type of base you have, whether it is a soft base or a hard base. Thank you for watching my video. If you love my video, please like, share and subscribe. If you have any question, please leave your question in the comment section. Thank you.